The last lesson in transformations that we're going to be doing are dilations. So a dilation is going to either decrease the object or increase the object. And you'll notice that this does not have that rigid transformation here. And that's because this does not keep the same the same size. A lot of times it will. For what we're doing, it will keep the same shape, but it will not keep the same size. So a dilation either decreases, so makes it smaller, or increases, makes it bigger. So this changes the size of the original figure by multiplying by the scale factor. And then again, these become only similar. They'll stay the same shape, but they're not going to stay that same size once we multiply them. All right, so first thing this says is dilate your rectangle, ABCD, by a scale factor of 2. So in other words, we want to dilate or multiply, make this 2 times bigger than it already is. So the first thing we're going to do is we're going to multiply each x and each y value by the scale factor. To get the image points. So I'm going to start. So I'm going to multiply my x's by 2 and I'm going to multiply my y's by 2. So I'm going to times each of those by 2. So I'm going to do negative 2 times 2 is negative 4. Negative 1 times 2 is 2. So my new point would be at negative 4, positive 2. A is here, A prime is there. And then I go to B and I multiply x by 2, so 2 times 2 is 4, and 1 times 2 is 2. So B would be at 4, positive 2, B prime. C was 2, so 2 times 2 is 4. 2 times negative 1 is negative 2. 4, negative 2. There's C prime. And your last one, negative 2 times 2 is 4. And 2 times negative 1 is negative 2. So this one, oh, I forgot my negative on that. This would be negative 4. Oh my, let me just rewrite that. So you have negative 4, negative 2. So we end up at negative 4, negative 2, and this would be D prime. So you can see that this got 2 times bigger. So algebraically, we took each x and each y, and if you remember, we multiplied it by 2. So this becomes 2x, comma, 2y, or whatever your scale factor is, times each x and times each y. All right, now, why do we need our scale factor? So your scale factor is going to be, the scale factor is a ratio or a fraction of corresponding sides. So the pre-image and image are similar. They're not congruent, they're similar. They're the same shape, but different sizes. So if your scale factor is greater than 1, like on this one right here, we had a scale factor of 2, then the figure is going to get bigger. So it will increase the figure. If your scale factor is less than 1, so if we're timesing by like 3/4 or a half or a 0.8, we're not timesing by the whole thing, so this one will get smaller. So greater than 1, bigger, less than 1, smaller. So if it is 1, if we multiplied by 1, it changes nothing. So it will, this should say keep the figure. It will not change the figure. Keep the original figure. It doesn't change it at all. It won't change it at all. So the hardest thing, most of you guys don't have a problem multiplying by the scale factor, but you do have a problem finding the scale factor. So let's go over how we do this. So you're going to choose any point. Again, we have pre-image, nice clean copy, image, the one that's been marked. And then we're going to look at either the x or the y value from that point. So let's say that I pick, I'm going to pick point R. So for me, I'm going to pick point R, okay? And I'm going to set up a ratio and I'm going to simplify. So I found point R, and then I'm going to choose the x value. And to do this, your scale factor, I should have written this, is the image point over pre-image. So I'm going to take my point R, and I want x prime, and I'm going to put it over R and just the x value, and then I'm going to simplify. So I find R and R prime. So R prime x value was 5. R x value was 2. If I put that in, it does not that's as low as it gets, is 5/2. You can change it to 2.5 if you want, so that you know that you're going to times by each one by 2.5. But if you look at this, my original R was 2. Again, original is this one that's nice and clean. My R prime was 5, and then the x value or the y value was in between there. So this is 5 and 2.5. S was, if you look at S, it was the same thing. This one is 5 and 10. And T is at 10 and 2.5. So I took, and you could do it even if I took my y values, it would be the same thing, because I would have taken, you could do any value, but I'm going to use S. So S prime would have been 10 over my original S value, which was 4. So 10/4 would still simplify to 5/2. So the algebraic representation for this, again, you would be 2.5x times 2.5y. And again, it's the pre-image, so original, just kidding. It's our image, so the moved item over original.